Okay, today we're going to be talking about molecular formulas, and to recap, molecular formulas is the next step after empirical formulas. If you recall, empirical formulas are the lowest ratio of elements in a compound, whereas molecular formula shows all of the elements and the total number of each in a compound. Okay, so molecular formula. Oh, let's go ahead and get this in our notes, please. Molecular formula is also known as the true formula, and molecular formula is the total number of each element in a compound, the total number of atoms of each element in a compound. All right? What we're going to be learning today is how to calculate it or come up with it from data. All right. Yes. Now, going along with this, guys, as we're doing this, I'm going to point out we are reviewing some of the problems that we have done. You have to do those problems in order to answer this, because I had somebody ask yesterday, will the final be over the entire semester? Yes, but that's okay because each unit's kind of over the whole semester, because we just keep adding to it. So literally, I could write 2 questions for a final if I wanted to. Now they'd be long questions, but 2 questions could cover pretty much everything we've done this unit or this semester. All right, I don't do it that way because if you mess up just one little thing, it would throw the whole thing off. But it's not like last semester where you had to go back, hey, we haven't covered this for like a month or 3 months or whatever. Everything we're doing keeps reinforcing what we've done. All right, now, in order to calculate, you don't need to necessarily write this line. In order to calculate, you will need the empirical formula, okay, which may or may not be given. The easier version, they give you the empirical formula. The harder version, and again, it's not harder because we learned how to do it, but it's just a little longer. They give you the percentages, and you have to calculate out the empirical formula first, and then use that in this, all right? You will also need the empirical mass. It could be given, most of the time it's not. You just calculate empirical mass. It's just the formula mass of the empirical formula. All right, and we're going to do that today, just to review. Okay, and then you need the molecular mass. All right, molecular mass can be found experimentally. All right, sometimes by looking at melting point, there's different ways you can do it. All right, but for our practice in this class, they must give you molecular formula. If they don't give you molecular formula, see me, because that means I messed up writing the problem. All right, I have to give you the molecular formula. You cannot find molecular mass. You can't find molecular formula without having the molecular mass. All right. And the last thing that, I'm going to rewrite this. I've got it typed out, but I'm going to rewrite it because it makes more sense if I write it out. Okay? So, those are the 3 things you must have. Now, when we're looking at it, all right, I'm going to abbreviate empirical formula just EF. I'm going to abbreviate empirical mass, EM, and molecular mass, MM. So, if you want to underline that so you'll know, all right? The way to find molecular form, am I okay to scroll or no? Yep, okay, cool. All right, the way to find it, I kind of came up with an algorithm just basically from the verbiage in a lot of books that said, well, you're going to do this, this, this. So I came up with an algorithm to write down, and if you can remember this, it makes it really easy to do. Molecular formula is going to equal, all right, you're going to take the molecular mass, all right, over the empirical mass, the answer to that times the subscript of the empirical formula. So whatever you get for an answer here, you multiply here and here. This answer must come out to be a whole number, or really like within a few hundredths of a whole number that we can round to a whole number. All right? If not, we made a mistake somewhere along the lines. Okay? This is why these problems I can't just go, oh, I have to have calculated out the problem ahead of time or have actual data. You can't just make these things up. Like converting grams to moles, moles to grams, all that kind of stuff. I can just make up a problem. We can use whatever numbers. These must work out perfectly. Okay? So one of the things I always suggest doing when doing these compounds is make a little chart, or doing these kind of formulas, make a little chart where we have which is our molecular mass, our EM, which is our empirical mass, our EF, which is our empirical formula, and then of course our final answer, the molecular formula. All right, I'll just abbreviate that as mole form. Okay? All right, so I'm gonna write out a sample problem down here. I'm gonna go ahead and move this. Write out a sample problem and then we'll work it out together. Now, this is going to be the easier of the two types because I'm going to give you the empirical formula in the problem. Okay? So, if you want to write the problem out all the way, you can. If you just want to pull the data out of it, like you're looking at it in a book or off a worksheet, you can do that as well. It is whichever you are more comfortable. All right? So, a compound has an empirical formula of CH, which would be C1H1, all right? But we don't show the ones normally on one step. We are going to. I'm going to show you why here in a minute, okay? It is also found to have a molecular mass of 117 grams per mole. Find the molecular formula. Okay? So a problem might be written like this, all right? So first of all, we survey the problem, and what data here do they already give us in the problem? So what data do they give us looking at the problem? Anybody? Yeah.
What the empirical formula is?
Yeah, they give us the empirical formula, so we go ahead and put that here, CH, okay? And then what else do they give us? Yeah. The molecular mass, very good. So we can go ahead and fill that part in. 117 grams per mole. All right? So we're missing the empirical formula and of course the molecular formula because that's what we're going to calculate at the end. The empirical mass. So to find the empirical mass, we do it just like we do for formula mass. Right? How many C's are there? 1. How many H's? 1. All right. Then times their mass off the periodic table. What's the mass carbon on the periodic table? Do you guys remember?
12.
12. Very good. All right. 12.0. And hydrogen? 1.0. Good. So we multiply that out. We get 12.0, 1.0. So the total would be 13.0 grams per mole. Okay? Not too hard, right? That's something we've done probably at least 100 times so far now, right? It seems like, because we're doing it on all our conversions, Okay, so that should be, again, when we get to the final and you have to do one of those, that'll be an easy point, right? Okay, so now we're going to use this algorithm and we're going to calculate our molecular formula. So, molecular mass, 117 grams per mole, over empirical mass, 13.0 grams per mole. All right, and all of that times C. Now here I'm going to go ahead and put the ones just to identify that that's what I'm multiplying by. Okay? All right, 117 divided by 13. Anybody done it yet? All right, I will. 117, oops, let's get it over here. 117 divided by 13. And this one comes out to be exactly 9, right? So this together equals 9. So I'm going to take that and distribute it to both of these subscripts. I don't know if this is 100% the correct mathematical way to write it, but I'm going to. So what's 1 times 9? 9. What's 1 times 9 again? 9. So it'll be C9H9. That's it. The molecular formula for this compound would be C9H9. I'm not even really sure this is a real compound. I just kind of made it up. C6H6 is a real compound, but that's benzene, I believe, which is a carcinogen, so be careful. All right. Okay. You guys got it? Can I move it yet or no? I'll give it a minute. Did you guys notice, have you guys seen some of the geese and ducks flying back north lately? You guys ever notice how one side is longer than the other on the V? Do you know why that is? It's got more geese in it.
Well, yeah, that's.
All right, sorry, bad joke. Okay, you guys ready? Can I go on? Feel free to steal those jokes. Psst. All right, let's do, this is the one where we have to do 2 steps. We have to find the empirical formula first and then the molecular formula. Sometimes you can actually cut out a step, but I'd rather make sure we do them all the same way. So we're going to do the empirical formula and then molecular formula. It really, you can kind of cut out a step, but it doesn't really save you that much time. So I like to do it this way. I do know some professors and stuff will show it a slightly different way. But if you understand my way, their way, you'll understand as well. Okay? So, let's take a look. So this is the way, again, oops. This is the way it might be written on a problem, okay? So, an analysis, you do not have to write this all out word for word. You can just take out the data we need. An analysis of a compound, look how good my handwriting is, shows that it has, or it is 40.0, that's a 4, 40.0% carbon, 6.7% hydrogen, 53.3% oxygen. Okay? Further testing. Further testing. Reveals, ooh, big words, its molecular mass to be, oh, that's 2 words, to be 360 grams per mole. What is the molecular formula? Do you guys like when I talk real slow like that?
No.
Yeah, that's annoying, I know. Sorry. Okay, so we make our chart. MM, EM, EF, and then molecular formula. Okay, like that. All right. What did they give us that we can fill directly into our chart? The molecular mass. Did they give us anything else that goes directly in our chart? Nope. That means we got to find our empirical formula and then find our empirical mass, and then we can use that to calculate our molecular formula. So, to find the empirical formula, what do we got to change the percents to? Percents become what? Grams, yeah, grams. So 40.0 grams of carbon, 6.7 grams of hydrogen, and 53.3 grams of O. And what do we got to convert those to? First step in finding empirical formula? To moles, very good. So 1 mole C, 1 mole H, and 1 mole O. Now, so if we have grams on top, where's it got to go on the next step? Bottom. How many grams for carbon? We just talked about its mass. What's carbon's mass? 12, there we go. 12.0 grams. What about hydrogen? I've already got it written. 1.0 gram. All right, and what about oxygen? 16, there you go. All right, so we're gonna do some division here. So 40 times 1 is 40 divided by 12. $3.33, is that what you guys got? And then 6.7 divided by 1, what's that gonna be? 6.7. All right, and then 53.3 divided by 16. $3.33 again. All right. Okay, so what's my smallest number? 3.33. So we're going to divide them all by 3.33. All right, so the top and bottom are easy. What are they going to be? 1. All right, the middle one is kind of easy. What do you think it's going to be? 2. Yeah, and we can look at it. 6.7 divided by 3.33 actually comes out to be 2.01. That's within 100th. We can round that. So it becomes 2. So our empirical formula will be CH2O. So we know this is a carbohydrate, right? Carbohydrate. We talked about that before, right? Carbohydrate. Okay, so we find the empirical mass. All right? Well, what's 1 times 12? What? 12, right? What's 2 times 1? And 1 times 16? 16. What's 12 plus 2? Plus 16? 30. So our empirical mass is going to be 30 grams per mole. Okay? You guys see how I got that? I just used what we already had set up because we already had their mass here, we had their numbers here, and multiplied it out and made it a little easier to do instead of having to rewrite it. Does that make sense? If you want to rewrite it, go ahead. That's not going to hurt you. All right? Now, we're going to use our algorithm again, right? Oh, it's always cool to say that word. Our algorithm, which is the mm over em times the ef. So our mm is 360. Our em is 30. Our ef is C, and this is where we're going to put the ones in. C1, H2O1. What's 360 divided by 30? What's 36 divided by 3? 12. You can do that. Have you guys ever been shown that in math? I'm sure you have, right? You just, if they both end in 0, cancel the zeros.
Yes.
Yeah, it makes it easier sometimes. So 12. What's 12 times 1? 12. So C12. What's 12 times 2? 24. And what's 12 times 1 again? 12 again. So the molecular formula of this compound is C12H24O12. Oh, any questions? Okay, let me pause the video and I'll ask for more questions just in case you want to ask off air.